Cloudflare global outage caused by misconfigured WAF rule. A DevOps Postmortem. Imagine it's July 2, 2019. You're sitting in front of your monitors when suddenly, the internet starts to fracture. It isn't just a local glitch or a single site going dark. It's a massive, sweeping failure of the plumbing that keeps the modern web alive. Within minutes, thousands of websites served through Cloudflare are throwing 502 bad gateway errors like wildfire across the globe. By 1345 UTC, the alarms start screaming, not for one service, but for an entire network infrastructure buckling under its own weight. CPU utilization is skyrocketing toward nearly 100% at points of presence worldwide, as if something invisible and catastrophic has hit the backbone of the system. In less than 30 minutes, a silent piece of logic becomes a digital sledgehammer, crippling traffic for millions of users. We don't know why it happened yet, only that the scale of the damage is staggering and the silence from the dashboard is deafening. Imagine a company that sits at the very edge of the internet, the gatekeepers for millions of websites and services globally. That's Cloudflare. They aren't just a service. They are the massive infrastructure layer that protects your data and keeps traffic flowing smoothly across the web. On July 2, 2019, this powerhouse hit a catastrophic roadblock because of something as deceptively small as a single line of code in their Web Application Firewall, or WAF. When an automated process pushed a minor update to XSS detection rules, it introduced a poorly written regular expression. This tiny mistake triggered catastrophic backtracking, causing CPU utilization to spike to nearly 100% across their entire global network of points of presence. Suddenly, instead of protecting the web, their servers were choking on their own logic, throwing out 502 bad gateway errors and effectively silencing huge swaths of the internet in under 30 minutes. For any junior dev listening, when your core networking layer fails like this, the world stops. It was a standard day in the trenches, or so it felt. For Cloudflare, things were moving at the usual clip, managing the massive flow of traffic across their global network. Then came the routine update. At exactly 1342 UTC on July 2, 2019, an engineer pushed what was supposed to be a minor change, a single rule for XSS detection within the Web Application Firewall. It was meant to be a surgical strike, a small refinement to bolster security. But tucked inside that deployment was a poorly written regular expression. Because of the way these rules were deployed globally all at once rather than through staged rollouts, the system didn't have to breathe. What started as a tiny configuration tweak was about to turn into a catastrophic engine of failure, waiting only for the first wave of real-world traffic to hit those flawed lines of code and trigger a chain reaction. It started with a routine update, just another day of tightening security screws. At 1342 UTC on 2/2019, an engineer deployed a minor change to XSS detection rules via an automated process. It looked like standard procedure until it wasn't. By 1345 UTC, the first PagerDuty page hit the desks, screaming about a WAF fault. Within seconds, the alarms multiplied into a deafening chorus of failures. End-to-end tests were crashing, global traffic was cratering, and reports flooded in from points of presence worldwide showing CPU utilization spiking toward nearly 100%. This wasn't just a local hiccup. It was a systemic meltdown. Visitors across the globe were hitting walls of 502 bad gateway errors as the network struggled under the weight of a single, poorly written regular expression. In those opening minutes, the engineers weren't looking at a bug, they were watching their infrastructure buckle in real time. It started with a routine update, just another day in the trenches. At 1342 UTC on July 2, 2019, an engineer pushed a minor change to XSS detection rules via an automated process. It looked harmless until it hit the wire. Because the system lacked a staged rollout and a critical protection mechanism had been stripped during a previous refactoring, that single misconfigured regular expression acted like a grenade in the engine room. By 1345 UTC, the cascade wasn't just a metaphor. It was a physical reality of CPU exhaustion. Across the global network, processing units spiked to nearly 100% as they choked on catastrophic backtracking. This didn't just slow things down, it crippled the infrastructure, triggering a wave of 502 bad gateway errors for anyone trying to reach proxied domains. In minutes, a localized logic error metastasized into a global meltdown, effectively silencing massive swaths of the internet. It all came down to a single, poorly constructed regular expression buried inside an XSS detection rule. When this update pushed out, at 1342 UTC on July 2, 2019, it triggered a phenomenon known as catastrophic backtracking. Instead of processing traffic normally, the regex engine began spinning in circles, causing CPU utilization to spike to nearly 100% across Cloudflare's global network of points of presence. Because the WAF rules were deployed globally all at once, rather than through a staged rollout, the impact was instantaneous and total. To make matters worse, a critical protection mechanism designed specifically to catch these high CPU regex spikes had been accidentally stripped away during a previous refactoring project. This left the system defenseless against a logic error that effectively turned their own security layer into a distributed denial-of-service machine, choking off HTTP and HTTPS traffic for millions of users in under 3 minutes. Imagine a single line of code, just one poorly written regular expression crippling an entire global infrastructure. When that rule hit production at 1342 UTC on July 2, 2019, it didn't just break a minor feature, it triggered a catastrophic, bad gateway cascade across the internet. For nearly 30 minutes, users attempting to reach any site proxied by Cloudflare were met with 502 errors as CPU utilization spiked toward 100% across their global network of points of presence. This wasn't a localized hiccup, because the WAF rules were deployed globally in one go rather than through staged rollouts. The blast radius was massive and immediate. It effectively paralyzed the front door for thousands of domains simultaneously. While the primary fix came within minutes of identifying the cause, the sheer scale of the impact meant that even internal tools like Jira and the control panel were sidelined, leaving engineers fighting the fire while half the web stayed dark. The clock hit 1342 UTC when a routine update to XSS detection rules went live, and almost immediately, the house started to burn. By 1345, PagerDuty was screaming. Reports flooded in from popes worldwide showing CPU utilization spiking to nearly 100% as that single, poorly written regular expression triggered catastrophic backtracking. It wasn't just one site, it was a massive wave of 502 bad gateway errors across the entire network. The team had to fight through a fog of war where internal tools like Jira were failing because they relied on them, the very services currently drowning in traffic. They knew they had to move fast to stop the bleeding. At 1402 UTC, they pulled the trigger on a global termination of the WAF managed rule assets. Within minutes, at 1409, the CPUs breathed again and traffic stabilized. Only after hours of grinding through the code did they finally re-enable the rules with a verified fix by 1452. The fix wasn't a surgical strike, it was an emergency amputation. At 1402 UTC, realizing that one rogue regular expression was choking CPU levels to nearly 100% across their entire network, engineers issued a global termination on the WAF-managed rulesets. It worked instantly, dropping CPU usage back to normal and restoring traffic flow for those stranded by 502 errors. But they couldn't just leave the gates open forever. By 1452 UTC, after identifying the specific offending rule in the pull request, they rolled it back and verified the fix through rigorous testing before re-enabling the rules globally. To ensure this nightmare wouldn't repeat, they moved toward more robust regex engines with runtime guarantees like RE2 or Rust, specifically designed to kill catastrophic backtracking before it could cripple the infrastructure again. They also overhauled their test suites to catch high CPU consumption issues long before they hit production. Look, if there's one thing this wreckage teaches us, it's that routine is a dangerous word when you're operating at scale. This wasn't just a bad line of code, it was a failure of safety nets. When that single misconfigured rule hit production and spiked CPU utilization to nearly 100% across the globe, it exposed how terrifying catastrophic backtracking can be in a high-traffic environment. They learned the hard way that their test suite lacked any real ability to detect these specific types of CPU consumption issues before they went live. Moving forward, the move toward engines with runtime guarantees like RE2 or Rust regex isn't just an optimization. It's a survival strategy against runaway complexity. And for those of us managing core infrastructure, it's a stark reminder: skip the staged rollouts at your own peril. If you deploy globally in one go without guardrails, a minor typo becomes a front-page catastrophe in under 30 minutes. That's how Cloudflare turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.